Hello, today we're going to go over finding the arc length of a parametric curve, meaning a curve that can be represented by two equations. It may sound a bit complicated, but it's actually very simple. Um, and the formula for finding the parametric arc length is pretty similar to the formula for finding the rectangular arc length. And the formula being, let's say L equals the integral from a to b of the square root of dx over dt squared plus dy over dt squared in terms of dt. Now, in order for this equation to be true, you have to have a curve represented by two functions. We'll call them x and y. And the derivatives of both have to be continuous over the interval a to b. Okay, this is going to be the only practice problem for today. We're told to find the length of the curve of y equals natural log 3t and x equals arctan e to the power of t from t equals 1 to t equals 5. Okay, so both of these are continuous over the intervals, or over the interval given. Let's start off by laying down what the formula for arc length is. It's the integral from a to b of the square root of the derivative of x squared. We'll call that dx dt, plus the interval for y squared. Sorry, plus the derivative for y squared in respect to t. Okay, so let's start off by finding the derivative of x. So that's equal to the derivative of arctan et. Now, the derivative for arctan x is 1 over 1 plus x squared. However, in place of x, we're going to use et. So we can say that this is equal to 1 over 1 plus et squared. We can just erase that 2 up there and move it over here. So we have e to the power of 2t. Now, we have to use the chain rule, because currently we found that the derivative for part of arctan et, and now we have to multiply it by the derivative of e of t, which is e of t. So it's quite simple. Now we have to find dy dt, which is going to be the derivative of y. And it's quite simple since it's only natural log 3t. And we're going to employ the chain rule once more. So the derivative of natural log x is going to be 1 over x. In place of x, we're going to use 3t. So we end up with 1 over 3t times the derivative of the inside function, which in this case is going to be the derivative of 3t, which is 3. So the derivative of natural log 3t is 3 over 3t, which is just 1 over t. Okay, now we can say that the arc length of this curve given is equal to the integral from 1 to 5 square root of, in parentheses, et 1 over e to the power of 2t squared plus 1 over t squared in respect to dt. Okay, I just plugged that into my calculator and I ended up with 1.654. So the length of the curve given by those two equations from t equals 1 to t equals 5 is equal to 1.654.